For this question, we're going to use the chain rule to find the formula for the derivative of absolute value of x. So if we define a function f of x to be absolute value of x, remember the formula that the absolute value of x is actually equal to the square root of x squared. Let's use that fact with the chain rule to find the formula for f prime. And then afterwards we'll think about for which values of x is the formula valid. So this is the idea for this question. F of x is equal to the absolute value of x. That's the definition of f. And this is not in a good form to take the derivative of, because we don't have a formula for that. But since this is a true statement, the absolute value of x is exactly equal to the root of x squared, why don't we replace that, and then now we know how to find the derivative of this using the chain rule. Why? Because we know how to find the derivative of root anything, and we know the derivative of x squared, right? Do you remember what the derivative of root x is? Yeah, I think it's worth memorizing. It's 1 over 2 root x, right? So let's just remember that, and let's use our chain rule to find the derivative of this. So the root of anything, it's going to be 1 over 2 times the root of that thing times the derivative of that thing, right? In this case, the thing that we're ignoring here is x squared. So let's fill that in. So there we go. Now let's just recopy this and finish our derivative. The derivative of x squared is simply 2x. So there we go. Let's clean it up though. This 2 and this 2, they cancel. So we have x over the root of x squared. And why don't we go back now and replace root of x squared by absolute value of x. I'll just go over here. I'm going to erase this. Here we go. Here's our formula. F prime of x is x over the absolute value of x. And there's our answer. Now, which values of x is this valid? Well, we know we can never have 0 in the denominator. So that means x is not allowed to be 0 here. Now this formula might look a little bit, I don't know, exotic or whatever, but it's really quite simple. Let's just think about what this means. Let me draw the graph of absolute value of x really quickly. It's just like a V, right? So this is the equation of this line here is y equals x, and the equation of this line here is y equals negative x. You know the slope of any point on here is equal to 1, right? This is like 1x, and this is like negative 1x. So the slope over here of any point is 1. The slope of any point here of the tangent line is negative 1. And it's 0. The derivative is undefined, right? So really, this formula can also be written in the following way. The derivative is 1 if x is positive. It's undefined if x is 0. And it's negative 1 if x is negative. These two are actually equivalent. X over absolute value of x is precisely equal to 1 if x is positive. I hope you believe me there. You know, if x is positive, the absolute value of x is just x. So we have x over x, and x over x is 1. If x is negative, though, the absolute value of x is negative x, and x over negative x is negative 1. And it's 0, as we mentioned over here. It's undefined, this expression. So both of this formula here is maybe a little bit more compact, but it maybe hides the true nature of what's really going on here. This is really another way to make the formula even more clear. So this is what the derivative of absolute value of x is.